Sixth graders, rounding and estimation with decimals. Okay? So in lesson 2 in this chapter, we're going to round the numbers that have decimal points in them. Usually you're going to round them to the nearest whole number, but sometimes you'll round them to the nearest 10 or the nearest 100 if you're using front-end estimation. Remember the goal of estimation. What's the goal? Who remembers what we're trying to do with estimation? Yeah, be able to do the calculation in your head. So round the numbers in a way so that you can do the calculation in your head. Brilliant. So, if you are starting with a number like, well, let me just go to the first one. 7.3 plus 21 and 648 thousandths. Okay? Remember, we want to round the numbers so that you can do the addition in your head. Okay? So, we want to round them probably using front-end estimation, but in this case, can you add, what you have to ask yourself is, can you just add 7 and 21? Can you add 7 and 21 without having to round the other numbers? 7 plus 21? 21 plus 7. Matt?
Yes.
Yeah. 21 plus 7, 28. So we wouldn't need to change them any more than that. First, look at the whole numbers and see if you can add them. Allie?
Are we going to be doing our work in our notebooks or on the sheet?
On the sheet. So then you should write on the line 7 plus 21 equals 28. Okay? That's what you should write for the first one. Allison?
If you can do, why can't you do 7 plus 22?
Oh, you could do 7 plus 22. I guess if you rounded it, yeah, that's a good point. If you rounded this up to the nearest whole number, then it would be 7 plus 22. Okay? Yes?
How are you, I thought you were, oh, wait. Aren't you supposed to change from to 22?
Yeah, 22 actually. That's a good point. Because then you look at the place behind, and if it's a 5 or higher, you round it up. And if it's a 4 or lower, round it down. So 7.3 is rounded down to 7. And 21.6 is rounded up to 22. Okay? So that is a better way to round this one. All right? Now, let's say that we have to round a division question, like number 2. 11 and 96 hundredths divided by 3 and 25 thousandths. When you look at the first numbers,
12 and 3.
yeah, we could find two compatible numbers by rounding them to 12 and 3. Because we know that 12 divided by 3 is an answer without a remainder. So these numbers are compatible. Alright? So for division, you should use compatible numbers. Okay? Use numbers that divide without a remainder. How about, let's see, how about multiplication? Clustering is again the same as before. That's rounding the numbers to the same number and then multiplying. but on your worksheet, I don't see any that you have to use clustering for. Okay? So let's go to some multiplication. Like in number 3, 9 and 84 hundredths times 51 and 263 thousandths. Now when you're doing this, what you want to do is use multiplication that you can do in your head. Okay? So in this case, you're not rounding to the nearest whole number. You could, if you did 51 times 10, because that you could do in your head, or you could do 50 times 10 in your head. All right? So either answer works for this one, as long as you're consistent, or you get a close answer and you do it in your head. So 10 times 50 is 500. So that's a good estimate. Or, since multiplying by 10 is just adding a 0 on the end, you could do 10 times 51 and write 510. As long as you can do the multiplication in your head. Alright? Yes?
The real answer is actually 459, so is that close enough?
459.
Yeah.
For which one?
Or 9 times 51. If you're going to do it, it's 459.
Oh, for 9 times 51?
Yeah, 459.
So if you can do that in your head.
Yeah, because I do 9 times 1 is 9, and then 9 times 5 is 25, 459.
Uh-huh. So that would be a good way to do it. If you did that in your head, then you'd write 9 times 51 and equals 500 or 459. Okay? So make sure that you write it down, all right?
Okay.
Write down the calculation that you're doing.
But wouldn't 10 times 51 be 510?
That's right.
No. Oh, 9 times 51. I thought you said 10 times 51. So.
All right. So do all of these for tomorrow, since they're all estimation.
Can we do the backside too?
Yep, and the backside.
Here it is.